Hi, and in this video, I'm going to have a quick look at the camera tracker that is available in Nuke. Well, I should say in Nuke X. So just make it clear that the 3D camera tracker isn't available in the standard version of Nuke. It only comes with Nuke X, so there are slight differences with the applications. And yeah, the camera tracker that we're going to use is basically going to track the scene. So we've done 2D tracking before. This is a 3D track. It's going to track the scene and it's going to apply that information to a virtual camera afterwards. Okay, and it does this by identifying tracking points within the scene. So no different to any other tracking points that you've used before. It's looking for things with high contrast or patterns that are distinctive. It calls these features. So it's looking for specific features within the shot that it can use. And then what the software will do is it will calculate parallax, which is the change of position of objects at different distances. And from that, it can then extract the camera's movement. Okay, so let's just have a look at bringing in the camera. So I'm going to just do a search for one here, but it is a 3D camera, so it's available in the 3D grouping here, and you'll see there's camera tracker. So we can either bring it up from there or just do a search for camera tracker. But yeah, so let's have a look at how this works. So we're going to just connect this up to our source. I can connect it straight to the direct pipe going to the viewer, but I don't really need to do that here. And let's just have a quick look at some of the features on here. I should add there's basically 3 main steps with a camera tracker. First point is the track itself, okay, or track features, where, like I said, the software will look for specific features that it can identify and track throughout, or well, track for a certain point in time. After which, we will then solve that. So based on those tracking points, Nuke will disregard any sort of redundant points and figure out where the camera is and basically create what's called a point cloud, where those points will now exist within 3D space. And then the third and final step is the create option, where we can then choose to translate that data now to a actual camera. Yep, so tracking, converting that to a point cloud with the solve, and then applying that information to a virtual camera. Those are your 3 steps basically in this process. And there are a couple of other things you'll notice on here that that we also have. Obviously, input is the sequence. You'll notice it has a mask option on here. It's a bit unusual on this, where the mask is actually, the mask pipe is on the left. In most applications, nodes we've used, the mask input is usually on the right. So as I mentioned, what the software will do is look for any kind of points within the scene, and it's going to see how they move, and from that it can identify basically how the camera was moving, right? So it's kind of inverting that movement to some respect. Yeah. So if objects on the scene all start to move up in the frame, we understand the camera is starting to move down. And if everything on the screen starts to move to the left, we understand the camera is moving or panning to the right, perhaps. Yeah. So the software is able to look at the movement of the objects on the screen and then figure out how the camera was moving. So that can mean that if you have somebody, say, walking around in the scene, so you've got a person or you've got some other kind of object that is moving by itself that has nothing to do with the camera, the track wouldn't work, because obviously the software will assume that movement is related to the camera's movement. And so we have to make sure that the camera tracker is only used on objects here that aren't moving. I have noticed there's a person on the side of the screen, but hopefully they won't make an issue in this case. But I should just point that out, like I said. So if it's not that you can't use a camera tracker on a scene with a person, but you just need to mask them out. So what we would generally do is just use our rotor paint, just like anything else, and just draw around the areas we either want to remove or keep, depending on the settings we use. So if I just actually add that to my output, so I can actually see this on here, what I should be able to do, if I just go back to my camera tracker, settings, I say settings, but I recall that used to be called something else in a previous version. I think it was called tracking. So I'm just aware that it may have changed name again. I don't think so, but yeah. So I can click preview features, and hopefully that should bring up the points that it will track from. And so we can see those here. So let's say, like I said, we didn't want to track all of those because there are perhaps people in that shot. We can connect the rotor paint, and then if we open that up, so just using the standard Bezier tool we've used before, we could select arrange. I'll just draw around. There we go. An area. And if you recall, let's just quickly connect that up. Notice the alpha channel or the information is stored within this bit and everything else is black. So remember, by default, the software will keep the white areas and lose the black. The reason I mention that is just because we've drawn a shape. We then go to our camera tracker mask option and we can choose what we want to do. And in this case, well, we could even use it off the luminance or the alpha, but we want to invert it. So in other words, we want to keep the white bit and lose the black areas. Yep. Then you can see, yeah, I don't know why that's, yeah, I'm just thinking, why did I go for inverted? I would have thought it was luminance, but I guess not. Okay. But yeah, anyway, so there you go. And you can see it's keeping the section within the area I drew and losing the bits around it. So you could animate that if you needed to, so that it ignores anything where there's a like I said, a person or anything else that's moving. So I'll delete that for now. We don't need that in this case, and I'm just going to turn off the review features. So we've got by default it will track the whole shot, which is usually what you want to do. But if you choose not to, you can select from here. You can choose a custom range and add that if you like. Now it also has some options for the type of camera movement that you have. So by default it's set to free camera, which just means sort of like a handheld camera, but it does have rotation only, which so Nuke defines that as a camera that is stationary but rotating. It has linear motion, which is a camera motion which is on a straight linear path, and a planar, which is a camera on a flat path moving in two-dimensional plane. So it kind of gives you a few options there to try to refine or tell the tracker a little bit about what kind of camera movement is being tracked. Not just that, but we can add in information about sort of any kind of whether there's lens distortion. Now, focal length, you should, you would sort of select known and add in the focal length. And the film back, so we've got some presets, great. So if you know the camera, you can just sort of find it, yeah, and sort of say it was this camera, and that's great, you'll sort of have that. If not, you can see the units are set to millimeters, and usually you can find that quite easily. So I kind of looked up a digital SLR, for example, which you might use, and it sort of, what I'm getting is on that, it should be something like 22.2 by 14.8 millimeters. So you could look up the sensor size anyway and just add it in. In this case, I'm actually going to just keep it at unknown constant. So obviously unknown constant, so it's not changing. If we were zooming or anything like that, we'd go for varying. So I'm going to keep it at unknown constant in this case, because so this kind of goes against the things that we should do, but it's an old piece of footage, and while I have some information somewhere, I don't have it at hand, unfortunately, while I'm working on this. So we're gonna try it without that information in there. But like I said, if we were to add those details in, we should get a better track because it has a clear, correct setting of the it has the correct information about the camera's focal length and the sensor size and so on. So yeah, just quickly jumping back to settings. Another thing just to quickly point out that we can change on here as well if we wish to. So I mentioned those tracking points we find are called features. So here are the sort of the number of features that it will go up to. Yeah, so set the number of features for tracking. Now you can turn that up. So if you want to improve the track, just keep in mind that the number of features is related to the feature separation as well. So I'm just wondering what the 12 in regards to space sort of means. But generally, feature separation is the distance between or how far apart each feature has to be. And so usually one of the things you can find happens is if you increase the number of features, you may have to decrease the feature separation. But I was just interested in what how that number relates to what we see on screen. So it doesn't really say what units of measurement that is. And then we also have the threshold. And the higher the number, the more precise the tracker has to be, basically, in finding a tracking point. So if you're having issues, you might sort of want to go in and try adjusting some of those. All right, but in this case, like I said, so we've generally just applied this tracker. We're not using any of those other features that we sort of looked at, and we're just going to go through those 3 steps of track, solve, and create. Okay, just so you know as well, you don't need to have this in the direct pipe, like I said, so I'll just connect it like that to the viewer. You know, it's something that's just sort of tracking on the side. So let's try it like that. Okay, and let's track. And what you'll find with the tracker as well is obviously, like I said, so this is set to track the entire length of the shot, which is what it'll do by default. But what it will do is also it'll get to the end of the length of the clip, and then it will track backwards as well to improve the overall track. So yeah, you'll see it go both ways, all the way to the end and back. Okay, so my track is now done, and so I've got my little animated icon there in the corner. And so yeah, I can see those track points. I'm going to just solve that at this point. So I could convert that now to a 3D point cloud. So if I now press my tab key, I should be able to see those points within 3D space. So like I said, it's using the parallax between objects in order to determine where these actually exist in 3D space. Once I've done that, I'm going to then just sort of go to the create option, and I've got option to create a few different things. But in this example, we're going to just look at creating a camera. And so we've got it linked to our tracker. So that's fine. And we can just create our own separate scene and scanline renderer in order to convert that to a 2D set of images again, right? So our scene is going to go into there, a camera is going into there. That's just for our background, so we'll leave that. Right, okay, so there we go. So we've got that, and I've got an image which I'm going to just sort of place on here. Now obviously you may have done this exercise previously as a 2D track. We just want to sort of investigate, like I said, how to use the camera tracker now. So what we can do is, now that we have a 3D camera, actually let's just jump into our 3D view again. If I press play, you should notice, hopefully, no you won't because it's not connected. So let's connect this up for a second to our viewer. And if we now play this, we should see that the virtual camera is moving, hopefully in a similar fashion to the real camera that was there on when it was, well, that filmed that scene. Okay, so if I jump back to my 2D view now, I'll have obviously lost this because it's not sort of linked to anything. I could have it connect it as a background, but what I would suggest you do actually is use a merge, where this will be the foreground and the background comes in from there. Again, this allows us to separate out the background and the foreground. So if we need to then color correct or grade or do make any other adjustments to our image, we can do that at this A pipe, whereas the background comes in through the B pipe. So, right, we can now just create a card, and we could sort of have a look at where the wall is there and sort of apply that. What we can also do is actually, so I'm going to just put an image over this kind of fire exit section here. What I can also do is just select some of the features there. You'll see it sort of highlights the ones that exist then for that within the point cloud. So that's where it sort of assumes that is. So I can highlight some of those. I'm going to right click, and I've got a create option. And you'll see I can create a card. So I'm going to create a card. Now you may find something unusual happens because it may not have fully understood where those points are, but I'll sort of exactly, so I'll show you that. So I'm going to click that to the scene, and you can see there's a card, but it's in a weird sort of position. So what I'm going to do is I'm going to add the image in. So great, but it's kind of sitting, like I said, at a usual angle. So at this point now, I'm just going to go into the card properties, go to rotate, and I'm going to just set all those values to 0. So there's no rotation. Jump back, and you can see it's right in front of the camera, and so I'm going to actually just adjust its scale down in this case. So I'm going to just rescale it, and I'm going to reposition it in 2D, as in X and Y. So I'm going to just adjust that. There we go, something like that. perhaps. Okay, and yeah, I'm happy with that. And so, like I said, I should have a card now that's sitting in the same place as those points. And so there won't be any movement on this. There's no tracking applied to this. It's just a virtual camera is moving around that. So let's see how that does. Obviously, if you want to see that without the without all this other overlay information, just close all your um, panels down there, and then you should be able to see that. So we can see how that then tracks. Okay. Well, yeah, how the virtual camera is moving through that scene. So that's how we can use a virtual camera, at least, like I said, in Nuke. Now, keep in mind, like I said, with this example, we've put the card through here and we've got it in the A pipe, but there'd probably be more that you would then want to do. Certainly in regards to sharpness. Okay, so just notice again notice how sharp the details on all the edges are there compared to edges on anything else. You've got a little bit of, especially with the camera movement, you've got a little bit of blur and so on. Remember, you can adjust that in the scanline renderer as well. So it does have an option to adjust the overall motion blur. Where are we? Here we go. Sorry, multi-sample, and we can sort of change the shutter controls, which should help match that up a little bit better. Let's just try that a little bit just to demonstrate if we can. Oh, samples. I always get that mixed up. It's about the number of samples you take. Obviously, you can see I've turned it up a bit too high there, but just trying to quickly demo that. So what you can do is, like I said, try to adjust that so the camera movement creates a more realistic motion blur rather than trying to animate one yourself or anything like that. There's a virtual camera already moving around this card, and so all we need to do now is set up what, like I said, just some sort of shutter settings there on the renderer. As well as that, we might choose, like I said, to just grade it a little bit perhaps, and add anything else we want, like noise or grain. Okay, so all of that would go down the A pipe, and then we'd be finished with that. So give that a go, and not just the tracking, but have a little bit of a work on the poster as well to try to get it to composite a little bit better. Okay.